Hello and welcome to this, which is the 10th free webinar of our 2018 Smart Building series. And today I'm joined by John Petze, who is a partner at Sky Foundry and also Executive Director of Project Haystack. And we'll obviously mention a lot more through this webinar about Project Haystack. And we've called it the evolution of data and analytics in the built environment. Hello, John.
Hello, Jim.
And
Thanks
welcome.
for the opportunity. Yeah, I appreciate
Absolutely.
it.
Welcome back to the to this podcast webinar. Very happy to have you here again. So before we get started, the way that we're going to work today, we're going to first of all, John's going to go through a presentation, and then afterwards we're going to enter a kind of Q&A session. So very happy to take questions. What you can do is just type them in. I'll get the questions here, and then I'll be able to put them to John when he's finished giving the presentation. Beyond that, I just need to say as well, don't forget that this is being recorded. So if you want to share it with your colleagues, it will be up on our website probably later today or tomorrow. You can also subscribe now. You can subscribe on iTunes. We have a podcast on there. Just search for Smart Building Series. Also SoundCloud and also YouTube. So there's various different ways of you getting this content again if you want to share it with other people. So yeah, let's get started. John, over to you.
All right. Well, thanks. So one other housekeeping note was unfortunately Mark Peacock, who was going to join me, who is also part of the board of directors of Project Haystack. His flight got canceled. But the comments that we have and some of the information we want to relate, both Mark and I put together for this webcast. So Mark extends his apologies for missing it. So yeah, so one of the things, we've had other presentations with you, Jim,
Mm-hmm, yeah.
and this one I think is a little different because it reflects what we see happening out there, and so we really thought the concept of the evolution, that term was really key to this, because while data analytics is probably one of the most common things people have on their mind in buildings, we're really seeing an evolution in not only the technology, but I would say actually more importantly in the thinking of organizations around data, around concepts like a data management strategy, data assessments, et cetera. So we really do see an evolution. And of course, at Project Haystack, we're at the forefront of this because of the work that the Project Haystack open source initiative does, helps people work with data. That's what its goal is. So, data is a cornerstone of business, right? And having data and learning how to use it changes the way companies do business, right? Changes their ability to perform, to track their results, to now with machine learning and AI techniques to predict or better understand the meaning in that data. And I would say that there's no question it's a irreplaceable asset, right? Any modern organization has to be using data to run their business. But one of the things that when we started out at Project Haystack that we encountered is that while data was well understood in the CFO suite and on the manufacturing floor and those areas, there'd been a lack of appreciation and understanding of how to use the data from environmental systems, from the built environment, whether that be control systems, sensors, energy data, meter data, et cetera, that it really hadn't kept pace, and it didn't have the same tools, same, I would say, study and contribution from academic areas as data does in other areas. So, this is a good slide that you brought up here. Both a blessing and a curse, and we see this regularly. While we have our commercial roles, in our roles with Project Haystack, we're often asked, will you come in and comment on, data, help us understand, share best practices or whatever. And one of the things we see is that when people embark on an effort to utilize data, some of the first reactions they get are, I would say, a little bit of dismay, right? They run into challenges in getting the data, even though it's supposedly there in their systems. And they run into challenges that there's so much data that it can seem overwhelming once they open the box and find out what the various environmental systems in their facilities have for data. It can look overwhelming. And then the third area where they can end up being a little bit surprised is, or actually a lot surprised, is in the whole thing, the whole issue of what data modeling, data meaning, data tagging, which is where Project Haystack really got its start. But what that leads to, really, and people are understanding, is that they need a data management strategy, right? Data is an asset, so you need a strategy and processes and people involved if you're going to manage that asset. No different than any other asset, right? I mean, that comment is actually pretty straightforward, but we've seen, I would say, a maturing in the understanding of that. So what's involved in data planning, right? The first thing is this cultural component. People ask us, well, what do you see as, where are people really moving forward with data? Is it retail? Is it office buildings? Is it institutional? Is it, multi-site, fast food? What is it, right? And the comment I always make is it is totally independent of the type of facility, whether you're producing stuff in a factory or you're serving food or you're housing office workers or students in classrooms. The big difference we see in organizations is directly related to the culture. Is the culture open to utilizing data in how they make decisions? That is the most important factor. It isn't what type of facility it is. And so from that culture, if there is a data-driven culture that can understand this value in the data, wants to get that value, is willing to invest the effort to get that value, that leads to a strategy, right? And the strategy, let's not jump to the end. What value are we going to get out of the analytics? What's the strategy around our data? Where is it held, right? How are we managing it, backing it up, bringing it together? Do we even know where it is? Do we even know we can get all of that data? Once we're there, then the next thing is, how are we going to categorize it? You could use the word normalize it. It all leads to defining it with metadata, which of course again leads to Project Haystack as a standardized approach for doing that. One of the most important things people can do at the outset, right, is come up with some standards, and we've seen many organizations have done this, but unfortunately many others haven't, which is standardizing what you're going to call things. Let's go to a building automation example. Whether or not you've embarked on using the data for analytics and machine learning or any of those things, you should be able to standardize on the naming conventions so that there's uniformity, which is the basis of streamlining all of the following steps, right? The other thing is, to avoid data drowning, one of the things we always hesitated on was overhyping the term about big data, right? Is it big data? We think a better way to refer to it is appropriate data. And I'll give you a good example. You could have a 1 million square foot office building and all of the environmental systems, chillers, boilers, air handlers, hundreds of VAVs and sensors, et cetera, right? Wow, that looks like a lot of data. But you could also say that your data project is going to start with the energy data coming from the main meter. That's 2 pieces of data, kWh and kW. Maybe a third one, the schedules. Maybe a fourth one, the weather, right? And some other factors. So when we say avoid data drowning, we're really saying you want to match up what you're trying to accomplish against the data that you want to get involved with, survey, and dig into, right? We encourage people that you really should think about that first. Yes, it would be great if you could magically get all your data in a uniform format so you can pick from anything. Yeah, that would be. But the reality is that's not a luxury most people have. So we say, look at data as an asset, and what data you're going to go after. You could go back to a mining approach, right? A mining company has to pick a place to go. They can't go everywhere at once. So that's what we mean by that. And I think a lot of the things I'm bringing out they may sound like common sense, and in some ways they are. But as people, organizations embark on data, these basic concepts are really important to remember and build in. So yeah, let's talk a little bit about the obstacles people run into that may cause some of that dismay or surprise. Lack of sharing. Interestingly enough, because of the siloed approach of many organizations, you might say most, but certainly many of them, which were done for all good reasons, right? This part of the organization needs their data, and they had the budget to get it, and they invested. And it naturally ended up being not shared. And one of the things we like to point out is, don't assume because it's not shared that there's some, malintent associated with that. It's how organizations have developed, how the world has developed, that there are lots of silos. I think we saw, in the 90s and early 2000s, silos broken down around ERP systems and financial data. But there's a lot of silos around building data, facility data, the built environment. Associated with that, of course, is the ownership of the data. That's both internal, right, within organizations, do different lines of business, functional areas, they own the data. But organizations who are embarking on a data strategy need to consider ownership with vendors they may work with, right? If I use this cloud-hosted provider to collect, store, manage, and perform analytics and reporting on my building data, what are my rights to that data, right? If I buy this device, which generates data that I can actually access through a website, we can think of a smart thermostat or whatever, what are my rights to the data? Those are things that need to be looked into, because they are limited by contracts, end user license agreements, things like that. And so the point here is to understand that, and the ownership regime that you're involved with may be perfectly acceptable to you, but you can't know that if you don't understand it. So you need to understand the ownership both within your organizations, right? There may be reasons that the manufacturing data, hasn't been and doesn't want to be shared with other areas of the business because of some type of sensitivity. Maybe it could be used, if you're a public company, it could be used to determine what your revenue is going to be, and that could have effects on, how you financially report. So, as we look at these obstacles, it's important to consider that, the factors behind them may not be simple, and they may not be related to malintent. Data quality, right? Huge issue. In fact, I would say when, from our point of view, where we're very much involved in helping people utilize their data to analyze building systems and performance, et cetera, the data quality is one of the first things they run into. Quick, anecdote, met an organization, they had a very modern building, about 3 years old, high LEED rating, state-of-the-art control systems. We're ready to embark on data program, especially around applying data analytics. They had the building automation system. They thought they had all the data because every time they brought up a screen, they saw all the numbers flashing on the screen with the picture of the air handle, the chill of the boiler. What they didn't realize is none of the history logs had been set up because they had never tried to go look at them. They were just getting ready to start doing that. And it turned out none of them had been set up. This building, state of the art, had been running for a year and a half, and they didn't have any of the data from the startup, the commissioning, and the operational phase. That's extreme example of data quality. Let's go to some others. Meters go offline, cellular networks lose information, networks go down. Names get mischaracterized, units get set up wrong, meters roll over. There are unfortunately many different facets to data quality. Sensors read wrong, they're out of calibration. And that might be enough to say, wow, there's so many complexities here, maybe I'm not going to do anything with data. But I would suggest that the financial part of your organization wouldn't throw up their hands and say, oh, this is hard, there's problems, so I guess we just won't do financial reporting. You know, barriers to access. You know, when you see this on a slide, people are most often talking about proprietary limitations to get into the data from different systems. You know, there's a long legacy in the building automation, building controls market of barriers being there to accessing data. I think those have dramatically gone away. But you know what we find is a lot of people have a portfolio of buildings, and while the last 3 systems they installed may be open and accessible, the ones they installed 10 years ago, 8 years ago, 5 years ago may not have the same level of access. And that can be surprising, right? And a challenge. Reliability gets back to quality, but is actually slightly different point we're trying to make here is, you know, if you're dependent on the data for making decisions, are you, you know, what kind of assurance do you have that you're going to get the data in order to be able to perform those functions, and that you're not going to lose the data? Example, you know, you've been effectively managing your energy demand to stay below severe penalties from your utility company. In order to do that, you need feeds from your meters. What happened to make decisions on intelligent load management? You know, what happens if that feed goes down, right? Then another one, data overload. This is interesting because, you know, people, when they embark on a data strategy, they might think, oh, I've got to get every piece of data from every system, every sensor. Again, you know, I say go back to what are your goals? I think your goals should, you should really consider phased goals, right? You know, when you went to college, you didn't start the first year by saying, I'm going to learn everything about math first year. No, you had to start with, you know, calculus 101, right? So you should approach it the same way. Now, again, that fits the strategy. You want to have standards in place, practices in place to minimize these obstacles. So you want to think about them up front, but that doesn't mean you're ready to take on every piece of data from every system. And, you know, then I would go down the list to personnel. It gets back to the culture. People who understand the concepts and principles around data, that understand and can interpret the data the way it is being stored and reported or recorded in your organization. And of course, that leads to the last bullet where Project Haystack comes in is, you know, how do we label, tag, define, identify, and describe our data? But these are the obstacles that organizations will run into. Knowing about them up front, I think, is helpful, and because it can help you set your goals and phased plan and your strategy. So yeah, so you know, one of the things Jim and I talked about in preparing for this is how the conversation around data is changing. You know, over the last number of years, you know, the first thought of analytics and buildings, you combine those two terms and you're talking about achieving energy efficiency, comfort, reduced maintenance, response time. You're really talking about kind of applying analytics for fault detection, you know, identifying equipment problems, issues, et cetera, right? So you can respond more quickly, more efficiently, et cetera. Doing energy analysis so that you can benchmark your buildings, understand the cost implications of your consumption patterns. I think this is interesting. You know, we see more and more people getting involved in the data associated with their tariff rates, energy rates, because while it might be great to reduce your demand or consumption, electric rates and tariffs are very complex, and you may find that, you know, the same consumption has totally different cost impact under 2 different rate programs. How do you assess that? Well, guess what? You get a new type of data you have to get a hold of and understand, and that's the data associated with your tariff rates, right? To make sure that the energy pattern of usage and demand is appropriate for the tariff rate run. But other things that, you know, this level of analytics accomplished is, of course, you know, identifying, you know, outright faults like simultaneous heating and cooling, sensors with problems, changes in behavior of your building, you know, benchmarking against weather and past performance, comparing your portfolio, right? Comparing and benchmarking that's an interesting one, getting back to, not getting into data overload. One of the first things a lot of people embark on is get your energy data, benchmark your portfolio, assuming you have multiple buildings, find out the best and worst, right? You got limited time in a day, you got limited resources, use a little bit of data up front to identify where you should focus first, right? Where is the effort most likely to pay off? And again, I'll also mention tariffs might come in there because, two buildings, one may be more inefficient than another, but it might be on a tariff that makes it less of a cost impact, right? So that gets to analyzing spend and et cetera. So these are, I would say, traditional. It's kind of interesting to be here a few years into the data analytics journey for building owners and be saying these are traditional ways. These are really at the forefront for many organizations. But this slide really sets us up for the next topic because we're seeing data being used in other ways as well. Let's move on to that. This is where, data-oriented organizations are now seeing that they can use data. Space utilization, which can have dramatic financial impact. Understanding your space utilization, which has changed significantly, with the idea of people working at home, telecommuting, and things like that. Also using the data for occupant engagement for a couple of reasons. One, so people can report if they're comfortable or uncomfortable. But two, it's been shown, and I'll leave it to others to talk about the detail on behavioral science, but it's been shown that engaging occupants makes them more satisfied. Now, there's a balance there, right? We don't want too many things in our inbox, but we also don't want to feel like we're ignored. And of course, that leads to the whole well-being productivity element. And, a key factor or key concept around that is the 330-300 concept, right? The relative ratio of costs associated with building the building, the $3 a square foot, operating the building over a period of time, the 30, and the actual cost per square foot of what goes on in the building, which is employees supposedly being productive and generating income, and that's the 300. You see more and more conversation around that, and where does that take us? Data. We need the data about, space utilization because we want to optimize, how many people we can put in the building, right? That gets at the construction cost, but we also want the performance around, the energy, but we also want that well-being. And if, in the obvious case, an extreme case, if there's sick building syndrome or severe lack of comfort, people leave, they complain, they can't focus, etc. The other side is financial performance. I think some of the, encouraging things we've seen because, both at Project Haystack and in my day job at Sky Foundry, we're focused on helping people be more financially successful with their buildings. The financial performance of buildings, it has now been proven with independent studies that, an efficient building is more valuable than a non-efficient one. And so you can see, in some cases, you can see more financial increase in the asset value than the financial benefit you get in running more efficiently. In other words, the energy savings that can be dwarfed by the increase in asset value because, of course, they're looking at the operation of the building over time. So that's, an important concept as well that are coming into new ways data and analytics are being utilized, right? And what does this come back to, right? All this, I think, comes back to having a data-oriented culture, right? Do we appreciate data? Do we know how to use it? And do we have people who have the role to think about how they can use data to continue to improve the overall operations? So another big concept that we want to talk about that directly relates to data. So if we'll kind of switch gears and we've talked about the evolution in thinking around data. Now we'll go back to more of a technical oriented concept, this is the move to analytics at the edge of the network. And I'll preface this before we go on to the next slide, Jim. That I would say the first generation of using data has been quite cloud oriented, right? We're going to bring all that data to the cloud. But there are real challenges with that. You can't bring all of the data to the cloud. First of all, that's a challenge, right? The costs, there are costs associated with bringing it to the cloud. Bandwidth cost, over networks, it's not free. The type of hardware, memory, et cetera, So the idea that we're going to bring every piece of data from every IoT device to the cloud isn't viable, right? You don't need to, and you don't want to. And what we're now seeing is the move to utilizing that data. We use the word analytics for that, at the actual edge of the network. And so let's go on to the next slide. Interesting data point that by 2019, 40% of our Internet of Things data will actually be processed, analyzed at the edge or very near the edge. And this is an important trend that organizations need to understand as part of their data management strategy, as part of their energy efficiency and data analytics strategy, is the, I would say, dramatically increasing capability to perform those analytics at the edge. Okay. Now, why would we want to do that, right? Well, there's a number of benefits of doing that, but let's go on to the next slide and just talk a little bit more about what we mean by the edge, because one of the problems is we've had big data as a buzzword, analytics as a buzzword, and now we get to introduce a new one, right? Analytics at the edge. The edge. What's the edge? So what is it? What we really mean by this is that we want to perform the essential functions related to acquiring that data, okay, communicating with the end device, computing on that data, performing analytics, right, running rules and algorithms and KPI calculations, et cetera. We want to do all of that as close to the edge where the data is collected as possible. And in the architecture there, we just have an example of that little colorful logo. Obviously you can see that it's at the cloud, right? We have multiple servers, computers, et cetera, at the cloud or collecting data and performing analytics. And that's really been the hallmark of the first generation of analytics. But now you see it moving down into the building, and even further in the green section there, you see it moving right down into the equipment systems, into small, low-cost IoT devices that actually, perform the analytics at the edge. Now, what does that accomplish for us? So one of the things it accomplishes is data. We talked about data reliability, right? That data does not have to traverse the internet and external networks before it's collected, stored, and analytics are processed on it. What does need to go up over the network to the user or the cloud are the results. Well, that brings up the second major advantage you can see from this, is that we send less traffic over networks. Just the results go up versus every sensor reading from every piece of equipment in a building having to go up over the network so that we can perform analytics on it. And I'd make a quick analogy here that may help drive this concept home of, think about self-driving cars, right? We can't wait for the self-driving car to send a signal up to the cloud to make the decision, yeah, you got to put the brakes on before you crash, right? That's an example of analytics being performed out at the edge. Now, that doesn't mean the self-driving car isn't communicating data up to the cloud for other functions. An example I would relate there would be, think about if you use mapping software and it shows traffic jams. Well, how did that come up? That is data aggregated from many edge devices, cell phones, and how fast they're moving, right? Aggregated up to the cloud so that it can be assessed and analyzed to indicate where there are traffic slowdowns, traffic backups. So the point here isn't that it's all the edge or all the cloud. And I kind of mention that because it's I've seen there's a tendency that we want to go one or the other, and that's absolutely not what we're talking about here. Data is at every layer of the architecture, and analytics has to be at every layer of the architecture, because as it turns out, performing analytics, it's really a distributed computing challenge. And that's what we're seeing, is more and more capability, products on the market. And of course, that ties right back into the work we do with Project Haystack, as implementations of Haystack reference implementations for software that run on C code or other code that can be embedded at the edge. And you see, various manufacturers embarking on this and, extending their analytics down through the different layers of hierarchy. So this is an important trend related to data. When an organization is considering their data strategy, now there's a new thing they should be considering. Where do we want to collect, store, and perform analytics on this data, right? And what are the latency needs? How fast do we need the analytic results? How fast do we need that data, the analytic results, the reports? And what are the aggregation needs? Where do we need to aggregate it for portfolio level assessment, et cetera? All right, so let's continue on. So, if we're talking about getting benefit from our data, and, we use analytics, it's a good catch-all for that, come back to, what are we actually trying to achieve here, and what should be accomplished by it? And, one is increasing the lifespan of equipment systems, automation systems, mechanical equipment, by running it more effectively, by servicing it when it needs service, right? By understanding exactly what's happening. The other, though, is the interaction with humans, right? Providing better information on priorities, on issues, on costs to the people who are responsible for running buildings, giving them more clear, understandable, actionable information. That's really the end goal of analytics, right? Getting that information to the people who need it, right? So matching up against the needs of different operators. There's a lot of different constituencies in a facility, and we want to use that data to get the right information to people. All right, so circling back to Project Haystack, our organization. What's the role there? And if you move on to the next slide, Jim. Appreciate it. A bit of a review for people who've been to some of our previous webinars with Memoori, but also opportunity to catch up for those who might be new. What is the role of Project Haystack in all of these? This data revolution and data strategy, et cetera. And the challenge here is that Haystack addresses is that it's actually equipment systems and control systems and IoT devices. While they produce vast quantities of data, that data has poor, inconsistent meaning, okay? It's not marked up in a standard way, or hasn't been in the past. That's what Haystack is really addressing. It's trying to help you eliminate the costs, the barriers, the obstacles to utilizing the data from your systems. And what it provides is a standardized methodology, and the simple way I describe it is as a markup language. And the analogy I would make is, you can start up a web page today, right? Start up a website, publish information, whether that's for your product or your business or whatever, your services, right? And if I have the URL of your website, I can go to it, and immediately I can see everything you wrote. And you and I didn't pre-coordinate that. We didn't get together and say, I'm going to put this here and this here. How can I be able to go and read that? And the answer is that the web settled on a standardized markup language many, many, many years ago. It's called HTML. Now it's HTML5. But the point is, this problem was essential and agreed upon early in the stages of the web, right? I'm going to publish textual and graphical information. We have to have a standard markup format for it. Surprisingly, this didn't happen to control systems and sensors, et cetera, until recently. Project Haystack, we believe, is the most adopted, most complete markup language standard for device data of all types, and it's being adopted across the world and across many different verticals and many different applications. And that's really what it is. The simplest way to look at it is a way that we all mark up our data. So we define this is a room, air, temperature, sensor, outputting its data in degrees Fahrenheit. It's associated with this piece of equipment. It's associated with this schedule. All of those facts captured with a standardized approach to markup or tagging. So a quick update here, and then we'll have plenty of time for questions. If we go to the next slide, we're going to give the audience a little bit of an update of what's happening with Project Haystack. So the organization continues to move along well and continues to see good adoption. One of the most important announcements we have is that Haystack Connect, our biennial every other year conference, has been announced for May of 2019. We started the first event in 2013, had one in 2015, 2017, attendance, and the program continues to grow, get richer and richer. The 2017 event was a huge success, and the 2019 event has been announced. So we hope people who are interested in the topics of working with data, data strategy, of course, data tagging, tools for doing that, techniques for doing that they'll consider joining that conference. It's every 2 years. We have 3 tracks: working group tracks, business tracks, and then application tracks. Also, Haystack Connections, we launched a magazine 2 years ago, and we put out 2 issues a year. The last one had 50 pages of content produced by the community. And so the January issue is in development. So for those of any of people out there, if you're using Project Haystack, the editor would love to have you contribute some of your stories. The best place to do that is to go to the Project Haystack website and look at the blog. There's blog entries about contributing stories. One of the very important things that happened with Project Haystack in 2018 was official announcement between the ASHRAE BACNet Committee and Project Haystack and another organization called the BRIC Initiative, who's also working on data modeling standards, to work together to unify the work with the end goal of having it included in the next generation of BACNet. That's a huge step for Haystack, but it's also, I think, a huge step for the buildings market, that understanding that we need one approach to doing markup. We can't have 5 different versions of HTML. Well, we can't have 5 different versions of markup on sensor and equipment data. And finally, more members, more associate corporate members, more forum members, more working group members, more working groups. So we've seen really good growth in the organization. Some of the other things we're seeing is it being specified by government agencies, specified by commercial organizations, and not just for buildings. It can be used in industrial. It can be used with equipment systems of all type. We have people using it with fast food restaurants and the kitchen equipment, not just the environmental. So those are some key updates there. And let's go on to the next slide. So, to wrap up, my prepared comments, and we really do hope we get good discussion and questions today. Data management plan, right? That's the holistic way to look at this. You need a data management plan to assess your data, put that together so that you can, make fact-based decisions and drive better outcomes across all of the functional areas you're building. When you're talking about connecting to data, collecting it, storing it, etc., you have to have a strategy around that. You have to answer those questions, and how you're going to get the data from different systems. And part of that's going to be who owns it, who controls it, who's responsible for it, right? And as we talked about, new trends that are happening on, analytics at the edge. But the other thing is data velocity. What does that mean? More data is coming in faster. So you need to understand how you're going to deal with that. That's another reason that we see people doing analytics at the edge, so that the only thing that's come to the organization is the end result, the analytic result. And then finally, what's the right data, right? Don't get too tied up with the big data word. What's the right data for what you're trying to accomplish? Have a phased approach, have a plan, start your journey or initiative with analytics in a phased approach. So. And finally, and I know, Jim, as you said, that a lot of this will be made available. We do have a number of resources that we point people to on the project-haystack.org website. I'll just mention 2 more before we go into the Q&A. We had 2 really, the community produced, I think, 2 extremely important documents this year. One is really the on-ramp for people. It's called a Introduction to Project Haystack, a primer. really the on-ramp. How do you understand what we're talking about with data modeling, data tagging? Where do you get started with the thought process? And then the other one is really kind of the other end of the spectrum. In the United States, the state of Utah embraced Haystack, worked with a consultant, and developed an end-to-end model for applying Haystack tagging to all of the equipment systems in the state buildings. So that's a very comprehensive, real-world, practical implementation for virtually every type of building system you'd see. And they did that work, and then they published it back and made it open source for the community, so somebody can see not only the theory, but how did a major property owner tackle Haystack tagging of all of their systems. So those last two bullets there, really incredibly valuable contributions by community members this year to help people. And again, just remembering that Project Haystack is non-commercial, fully open source, all volunteer-based work. So those are my prepared comments, Jim, and
great.
maybe we have
John,
some questions.
Fantastic, and I'll make sure those, especially those last two links, are included in the show notes. As John said, these the slides will be up on the website along with the audio. So yep, all of this will be made available to everyone listening. Now is the time, ladies and gentlemen, for your questions. John is available and willing to answer any of your questions about Haystack, about data in general, all of those things. So please put them in. There's plenty of you listening today, so I'm sure you've got some things you'd like to ask. And from my side, I mean, I think I picked out quite a few bits and pieces you mentioned, and that I think are worth kind of unpicking a little bit. Culture was the really interesting one I think you talked about, and often something that I think I've overlooked when trying to understand about how people are using data in buildings. I mean, who are you seeing then that is responsible for identifying, for example, data sources from building technology, and in a sense, like how companies that you've worked with, both through Haystack and Sky Foundry, how are they reorganizing the whole of the business to be more open to using data?
Yeah, well, I'll try to break that down in a couple of points. One, the who, it does come down to the facility staff that's involved with the hard assets. But notice I said come down to them. Sometimes it's a bottom-up initiative, right? People in that part of the organization see the value, see from either anecdotal evidence or people at other organizations, or because they get involved enough on their own, they see the value of data, and they'll propose and drive proposals on using data and applying analytics bottom up. But we also see in other organizations that it comes top down. So there isn't a single answer to that. And I guess I get that that goes back to the cultural thing, right? A new sustainability or energy manager or other executive comes in, and maybe they have experience in transforming organizations with data, a previous organization or a previous functional area. And they look at the building side and say, do we are we using our data? Can I find the energy consumption on all of my buildings with a click?
Right.
No, I can't. Why not? Right? How come I don't? Have we benchmarked? Do I know my 10 best by 10 more? I don't. Why not? Right.
And where would this conversation be happening then? Like the C-level? Are we talking like CIO, Chief Information Officer, is then sort of driving this and saying, why can we not get be able to see this stuff?
You do see it there, but I wish I could say you always see it there, but you don't. We encounter organizations where, unfortunately, that's the barrier because of this. I think there's an odd situation associated with buildings and facilities, is that they are often considered a cost to minimize as opposed to an asset to increase in value and a path to increasing bottom line revenue. I think it's an unfortunate legacy that the buildings industry and the building and the professionals need to try continuously to overcome, right? And I have an example. There's two similar organizations. They have a similar portfolio. One of them is 6 years into utilizing data, and they continue to drive costs out of their organization, improve the bottom line every year. And the other one, almost identical, literally can't answer the question of, what are my 10 best and worst performing buildings? It goes back to culture, and culture can be affected from the bottom up. I can't say that I can point to, a recent example I've experienced where, one individual came in and completely revamped the organization, and, suddenly they became data oriented. It's a process, right? And what it takes is, I think, multiple people, that new executive finding a champion who believes that's in the facility side, or the facility side finding a champion on the financial side, and they talk together and educate each other, because, everybody's lives are pretty siloed, right? So
yeah, absolutely. I'm not actually getting any questions through. I think there might be. Sorry, guys. I think there might be an issue with the software here. But what you could do is send it in the chat box instead. See if that's working, and then. Yeah, sorry about that. A software issue. A couple more points from me. Well, I've got plenty I want to talk about, but I don't think people are too interested in just my questions. But again, the thing I pulled out was silos. I hear a lot of talk, obviously, still, and I'm sure it will continue for a few years, about building data being siloed. How are you seeing some of those barriers being knocked down? Obviously, I mean, the work you guys have been doing with tagging different types of data, but are you sort of saying that more systems are talking to each other now, and if so, where and how?
Well, I think there's two sides to that. The systems talking to each other in a way, and this is one of the things we try to help people understand. People say, well, wait a minute, we've had open protocols. That means I can buy a backnet controller from manufacturer A and manufacturer B, and they're supposed to work together in a network. That's just one facet of this challenge, right? One of the things we see directly related to your question is organizations saying, we are going to ensure that we collect all data from all built environment systems, right? So, and that's what we're primarily talking right now. And we are going to enforce normalization, hopefully with Haystack tagging, and uniform storage of that as a separate function that the different divisions or the departments in our organization, they will draw from, okay? So it's a new initiative, that new responsibility to get and store all the data, and then the functional areas draw the data that they need from that. Whereas in the past, it would have been a silo. Oh, I need the energy data. I'm going to do all the work, spend the money for that, and I got it over here on my computer or server, and nobody else even knows about it, right? Right? And we didn't have a discussion about the format, and we didn't have a discussion about accessibility. Those are silos. And again, silos doesn't mean they're impenetrable. It just means we constructed them separately and maybe didn't think about this or have the opportunity. So that's one answer. We're seeing people take on, as part of a data management strategy, that all equipment system data should be separately uniformly and centralized for collection, and accessible to the different functional areas in need. The energy manager, the space planning guy, the security guy, all of those people. That's one. As far as the systems talking to each other, by and large, all systems going in today are using one of the standard protocols. And people often think that means that there isn't this data tagging problem. And that's not true, right? And it kind of leads you through how people get drawn into that assumption, right? I have backnet system, 5 different manufacturers. I pull up a screen, all the data's there. But if I want to pull the data from those different devices, do they have the descriptive tags, the descriptions that make it understandable to another software application? Obviously, the BAS graphics system knows how to take the data out of the VAV controller and put it on the screen. But if I want to pull that data to a system for, where we're assessing occupancy and use, does it come with the necessary metadata so that application can understand it, right? And that's often missed by people because, if they see it on the screen, they think, well, it's easily available, and it's amazingly not true.
Yeah, it is complicated, but I mean, we've seen, and I'm sure you have as well, like some pretty very sophisticated examples of people doing some really great stuff with BACnet and Project Haystack. We interviewed a guy at Penn State University, part of their
Yeah.
facilities, and they've done some excellent work. So yes, I think these things are everything. Anything's capable if everything's possible if there's a will and a way to do it and a good use case and obviously the right skills. And that I guess is a tough one, isn't it? We have to have the right skills in the industry to be able to solve some of these challenges.
Yeah, but you bring up an interesting point there that really I think it's worth enhancing. People are at all stages of this data revolution. There are people doing tremendously advanced stuff with data. It's kind of like they made it through the hurdle. Data is part of their life, and once it is, now it's easier to say, "Hey, let's do this with it, and let's do this." Oh, that's a great idea, right?
Yeah.
And then there are organizations who are just beginning this journey, and they need to learn the most basic things about it. So we need, I think, people to understand that once you get over these hurdles, there's tremendous value on the other side. It's kind of like once I can drive a car, look at all the places I can go. But if I can't drive a car, I can't go anywhere, right? But I get that one skill, and now I can do all these other things. And we need to look at it that way.
Mm-hmm. Yeah, yeah, and it goes back to again some of the points you made earlier about starting 101, from the beginning, and you this is a journey, and you're maybe somewhere on the journey, but you have to start somewhere.
Yeah.
Something else I picked up, which I thought was very interesting. You talked a bit about improving data quality, and I'm sure there are various ways of doing that. But are there any sort of tips out there, specifically that people might be listening that are struggling with this? You can say, okay, well, here are some of the basic things that you could do straight away to help with that.
Well, data quality is a big topic, so I am gonna make a comment around Project Haystack. Data quality by tagging the data, by having a data strategy and a data plan, and saying that part of the process is to effectively tag the data. You identify issues, as they say, up the pipe they're occurring, as opposed to down at the end where you expected to get the data and you don't have it, and now what do you do, right? So it's interesting that because there isn't one answer to this. You may have one type of data quality problem. I'll give you an example. A lot of people have, low cost meters that happen to roll over, right? When they can only hold a certain amount of data and they roll over. And is that rollover behavior understood? And how do software applications adapt to the rollover to determine, the last reading was 65,000 and the new one is 3. What does that mean, right? Well, if you are going at this from understanding the data being produced by devices and you're going to tag it and apply it, you're probably going to encounter these issues, right? So that's one. The whole data management strategy brings this out and allows you to do that. The other things are addressed with, I guess, one of the things you see with data analytics is identifying bad sensors quickly, right? I need or want that temperature, pressure meter reading. And 3 weeks later, I discover I'm not getting it. Well, why is that? Well, because you're not using, techniques like analytics to be constantly watching your sensors for patterns that represent failure or out of calibration. So that's another tool on the data quality issue. Then you get into, hey, there's just missing data, and there are software tools. What do I want to do in this gap of data? Interpolate, refill with the data from last year. It's a tough question. There's no question that it is a tough question.
Mm-hmm. Mm-hmm. Yeah. And I thought your slides on obviously the edge analytics is interesting, and that stat about perhaps this change in again the topology and how networks, how we process data, and it makes sense. But I think if I was sort of to look at this from maybe the building owner operator's point of view, again, it's sort of technology is changing and it's moving at a pace that often isn't in keeping with the life cycle of a building. That's one of these fundamental issues, I think, of buildings, right? Is that they just move at a different pace and built at a different pace and have to last longer than a lot of the technology. And a question I hear a lot is, how do you future-proof building, how can you do that? Do you have any thoughts on that? Especially seeing as, now perhaps they've, someone's getting their head around, well, okay, we need to have sensors and we need to connect those to the cloud and do some processing there. But now we're perhaps moving to a more edge analytic network structure.
Yeah. Okay. So, on that quite, future-proof, right? I mean, how can we future-proof ourselves? Oftentimes when people say, well, I want to future-proof it so the hardware I buy, will be future-proofed. I don't know whether that's possible or even should be a goal, right? I mean, I bought a new phone literally less than a year ago. And announcements this week are that, it's going to be obsoleted shortly. I'm going to have to buy another phone. But you know what? How my data gets stored, where my photos go, where all of that will port to the new phone when I get it. So we have to think about future-proofing of what is reasonably achievable. And the data is. Having a data management strategy means that as products change, become obsolete, become unrepairable, that's a lot of things people are seeing. A lot of manufacturers of electronic equipment, they can't even get the chips to repair something that's 5 years old. They don't make them anymore. It's gone, right? You have to put in a new controller and it's going to work somewhat differently, whatever. But the data, there's a place you can future-proof. How? By ensuring that you have a strategy, by having a standardized naming convention and a standardized metadata tagging convention, so that when you switch, you say, I want to switch from software provider A to B, the data can flow, right? That's a place you can actually future-proof and a place people should focus on. Around the hardware, I think, it's moving faster, not slower, right? The stuff that's going into homes and businesses, et cetera, there's no way we're going to stop that from happening, right? I don't, I'm from, my position here, working with data and whatever, I know it's possible to future-proof around data. So.
Yeah, no, excellent point there, especially the analogy with the phones. I just wanted to finish with this slide as well. Like, I think that's a really interesting point you made about these new ways that the data and analytics are being implemented. And I think actually that's quite a shift in our business as well. We're not just talking about energy efficiency anymore as an industry. There's actually some really exciting applications.
And here's the trend I think is interesting about that, right? I've known companies out there doing space utilization optimization software. I've known them for like 8-9 years.
Mm-hmm.
But they've been out there in their silo having one conversation with the owner, not having the other people involved. But now what they're seeing is, well, wait a minute, you have data from these other systems that we can use to do the analysis for space utilization. We don't have to put in a separate parallel system. We can take it from the security system. We can take it from the HVAC system. We can take it from other things, right? And what that means is everybody drawing on this pool of data, right, for the various applications that the data feeds, as opposed to, I'm going to need a separate silo of data to do space utilization. There may be do things you need, but there's also existing stuff that if you can get is going to help you with that. That's what we're seeing as this comes together.
Yeah, and it's exciting, I think, for the industry, definitely. I think I just want to finish and say, of course, Haystack Connect 2019. Everyone put those dates in their diary, May 13th to 15th, 2019. And I'm sure we'll be talking a little bit more about it before we get to that day. John, I need to wrap up. It's coming towards the hour, and I guess just say thanks again. Super interesting subject, and I really appreciate you taking the time today.
Oh, happy to. This is really good. Getting the word out and helping the whole industry move forward with data is something that's really important to us.
Yeah, and I think there's some good takeaways today for people to understand this topic. Just finally from me, I'm sorry, apology, I guess, not for the question issue. I don't know exactly what happened with the software, but sorry we couldn't take your questions. Of course, if you do have questions for John or myself, I think you can probably forward Haystack. I'm sure you've got an email address there, John. if people have
I
questions.
do. I do. Yeah. Mine is John P. at haystackconnect.org.
There you go. And finally, as you said already, we've recorded this, and if you guys want to share it, it will be online tomorrow. And don't forget, you can subscribe to all of our content that goes on iTunes, SoundCloud. You just need to search for Smart Building Series. Thanks again. Thanks for listening. And John, thank you
All right.
for your time.
Thank you. Bye
Bye-bye.
now.